Barbara Grosz. I'm a faculty member in computer science at Harvard. My official title is Higgins Professor of Natural Sciences. I had passed my qualifying exams at Berkeley in computer science. I actually did research in theoretical computer science for that, having to do really with compilers and something close to what you would call system verification now. I had also previously done some work in numerical analysis, and neither of those was fields I was really excited about continuing in. And I was searching for a thesis topic, and I was fortunate to meet Alan Kay, who is many people know as the inventor of Smalltalk and the Dynabook, which is what led to the laptops we all carry around now. And Terry Winograd had just finished his dissertation at MIT, and Alan was sure that if once he got Smalltalk to work, and it was really just on paper at that point, it was just an idea, that it would be easier to write a dialogue system in Smalltalk. And so he proposed to me that I take as my thesis topic writing a program that could read a children's story and tell it back from one of the characters' points of view. And Alan was always for big, ambitious projects, and so I actually spent a year reading children's stories, reading literature about reading in children, and studying natural language processing, which I hadn't studied officially. At that point, two people from SRI came to visit me, Ann Robinson and Bill Paxton, and they said, if you're crazy enough to work on children's stories, why don't you come work with us on the SRI speech understanding system, because speech is easier than text, and the kinds of task dialogues we're doing are easier than children's stories. So they were right about the children's stories and the tasks. I had actually, at that point, come to realize that children's stories are really mechanisms for socialization and getting children to be part of the culture, and not very simple to read. And children's readers at that time the things to teach children reading from were so poorly written that it was no wonder that kids couldn't read. They weren't right about speech. It took many, many decades for speech to be conquered. So I actually left Alan's group and went to work in the AI Center at SRI on a couple of projects that had to do with understanding dialogue in task situations. You know, this is a long time ago. It was before 2001.
And I didn't. Arthur C. Clarke.
Well, I don't know. He probably was around, but I didn't read science fiction, so the answer is no. What got me really hooked on AI? So what I realized about all of the work I'd done in computing before, I was a math major as an undergraduate. There was no computer science major at that point. There were a few computer science graduate programs, but no undergraduate programs. I really love the solutions. I love mathematics. I love the solutions in theoretical computer science and numerical analysis, but I didn't like the problem so much. What really drew me into natural language processing, which is really where I started, is that I love the problems, and I thought that I had many more intuitions about cognition and language than I did about satellites, which is really what numerical analysis was focused on at the time. So that's what drew me in. And also, I think, and this was the reason I went to work with Alan, he and I had in common wanting to make two things. One was wanting to make computer systems easier for people to use, and the other was that we were both appalled at how computers were being used in education. In those days, the idea of computers in education, I caricature, but it's not too far off, is 2 + 3, the kid types 4, you say no, wrong, try again. The kid types 7, you say no, wrong, try again. I should say, when I went to college, I was going to be a 7th grade math teacher, so I was always interested in math and education. Anyway, I knew that that's not how you could teach kids, and so that was something else that Alan and I had in common. The early work I did was in dialogue and dialogue processing, and there I constructed the first computational model of dialogue, and that was really a tripartite model that had the language structure. It had a structure which we called attentional state that tracked the focus of attention, and it had something called intentional structure, which was tracking the purposes of the dialogue. And that's really, developing that was what the first decades of I did in my career. That intentional model required that we be able to model the plans of multiple agents. And up to that point in AI, the work in planning was all focused on what a single robot could do. And even people in the area of multi-agent systems relied on this individual robot planning kind of technology. And Candy and Seidner and I argued, let me back up and say there was work in speech act theory and dialogue that used those same single agent models. And Candy Seidner and I argued based on the work that she had done earlier in dialogue, and also what I just described to you about my work, that those models wouldn't suffice, that you needed a model of a collaborative plan. And so the next decades of what I did, my research, were focused on developing models of collaborative planning and examining the decision making that takes place under that, examining issues like interruption and when interruptions are okay, and information sharing. And that all leads to what my focus right now, which is taking those models of collaboration and, I guess as the trendy phrase goes, using them for social good. In particular, I have a joint project with a pediatrician at Stanford to develop computational tools for care coordination. So the healthcare world talks about teams, but none of the technology supports teamwork. And so we're developing technology to support teamwork. So I've always argued that we have since I became a senior researcher, that we have a responsibility to the public to explain what we do, to explain both not only the promise of our technologies, but also the limitations, and to as I said, I started out wanting to be a teacher, so to teach the world about the science and technology. I think organizations that, so CRA, we're here at a CRA meeting, is one of those. I think the American Association for the Advancement of Science is another. So participating in those organizations, different people have different talents. Some people are great at getting up and talking to 1,000 people. Some people love to be on television. I'm not one of them. Some people write. So I thought one of the I think important things I did for educating the public was to write a blog for The Atlantic in 2012, arguing that we should not be attempting to replace humans, but instead we should be building systems to complement humans. So I think different people have different ways of contributing to that, but it is part of what we're responsible for as scientists. So the answer is not that I could name now. I think I have reactions of the moment. I think if I had a criticism of the community, it's that it's too eager to talk about what it can do and too reluctant to talk about what it should do. And I think it's true for an interesting reason, which is until very recently it wasn't clear that we could do very many interesting things. And so there's now been this boom and computing has entered all areas of life. So when what computer systems did was help banks process money better or help scientists get satellites up into space, there was a very constrained part of public life that they dealt with. One of the wonderful things is smaller computers. Everybody has one. I mean, computing has been terrific for really increasing communication and building a global village, as it were. but we didn't track, therefore, that the audience for our technology was now the general public, and that we had to be careful about what we said technologies could do.
I love this distinction between telling the public what we can do and what we should do. Thinking out loud, I wonder if we don't tell the public what we can't do, what the boundaries are, what's hard to do.
Right. And you see this, I think this is especially true now with certain of the emerging technologies that have some intelligence in them. So I will go off in that direction for the moment, or also with technologies that that are about communicating and making communication more fluent, and technologies that are basically selling us things. That in each of those cases, that again, I mean, it's what I was saying. It's amazing we can do it, but then we needed to stop and say, but of these things, what should we do and how should we do them? We actually know from research in artificial intelligence, it's much harder to know what you don't know than what you do know. And then as several people have pointed out, and this is very important in the machine learning community, there's what you don't know, and then the unknown unknowns, what you don't know that you don't know. And people also are not very good at that. There's also evidence that we're not very good at predicting the consequences of what we build and design, and we see that in law as well as in technology. So people in government, people in the legal profession, they write laws and then, whoops, I didn't mean for it to do this. I think we have to develop a culture of looking for the unintended consequences, of thinking about how people might use systems in ways we never intended. You know, it reminds me of something that Charlie Rosen, who started the Artificial Intelligence Center at SRI, said to me. He said, "I won't believe we have a really intelligent system until it can figure out that my shoe is a good hammer." Okay, so there's the kind of leap you might want in a certain circumstance. We also have to start predicting the leaps that people will make in the way they'll use technology. And I want to put a plug in here for something which I know you care about also, which is this is something that we can't do alone as technologists, as computing people, as computer scientists. This requires bringing in people who have thought about societies, about people, about how people interact, about how people think. So the full range of the social sciences and the humanistic social sciences, and also people who think about ethics and what's right and what might not be right in certain circumstances. So it's computing is everywhere now, and it needs to bring everywhere into how it designs its systems. So I'm going to start with the amazingly positive things they do. We can have collaborations around the world. People whose jobs have these pauses for a moment can actually use those pauses to communicate with other people. So I'm always fascinated by how many people I see just, on the people doing construction on the street, and there's a break and they're communicating with somebody, or maybe they're reading the newspaper. I don't know what they're doing on their smartphones. It's made work easier in many ways. I mean, if we think, and it's gone from making it easier to write a document yourself to easier to write a document with many people. One of the things that Alan Kay and I aspired to do, which you'll probably laugh about, was to give to children in school the ability to write essays without having to erase. So when I was a child, if I made a mistake, I erased. And if you made too many erasures, your grade would get lowered. So you would start handwriting the whole thing over. I had a big lump on my finger from this. This is ridiculous. It takes away from the thought part of writing. So kids don't do that anymore. So it just makes it easier to write. If you think about how science is done now, it's been completely changed by the availability of computing and computing technologies. So I don't make predictions about the future. I always tell the story of when I was finishing my PhD thesis having a conversation with one of my colleagues who was also finishing his, and he said to me, "It's good we don't care about money because AI will never amount to anything that will ever make any money." So that's it. I have no crystal ball. Let me say instead what I think is important because of this way in which computing technology has become completely intermeshed with the way we lead our lives, which is it's really important that systems, especially in the workplace, and so I want to focus on that, are designed in a way that the jobs that people have are good jobs and meaningful jobs. And I can give you an existing counterexample, which is the field of healthcare. Electronic health record systems have made the practice of being a doctor worse. They don't support clinical care, and they put an enormous data entry burden on physicians. So all of what they may do down the pike for improving healthcare by collecting data is fantastic. But they weren't designed to enhance the delivery of healthcare. They were designed for the billing department, or the insurance, and you can see that. And they could have been designed, and in fact, I think there are several startup companies trying to break into a market. That's really a political decision. But they could have been designed to work with physicians to deliver healthcare. So, I mean, another example I can give you is in customer service. Which irritates almost all of us, many of the customer service functions have been taken over by computer systems, and then when the computer system fails, you get a human being. But they have been designed largely in this way that you first get a machine, and then you get a person. Makes for a bad experience for the customer, unless their request is so simple the machine can answer it, and it makes a not very good job for the person. If they had been designed instead for the person to answer the phone first and for the computer system to support the person in getting you an answer more quickly, it would be a better experience all around. Would you have saved as much money for the companies? We don't know the answer to that. I would love somebody to try and design a system that way.
That's reminiscent of your blog, though, because what you're saying is essentially instead of replacing that human's greeting process with the computer, design the computer to help the person do a better job. Exactly. So the article I wrote came out of that was the year we were celebrating Turing's birth, really, the 100th anniversary of his birth, and I was asked to speak in Scotland, and then I was asked to write this blog, and I basically started speaking about what question would Turing pose now, and I have no idea what question Turing would pose now. But the world of computing has changed enormously, and I would go through how it had changed, but the most important way is that it's permeating everywhere. It's not one person on a machine it's not like the telescopes that astronomers use, right? And in that context, I argued, so I said I don't know what he would pose, but I know what question I would like to pose, which is, could we build a computer system that would function over a long period of time, not just one shot, as an effective teammate? One that therefore it's not that you would think it was a human being. It wasn't going to cover up its personality, but it would behave so well that it was as if it were human. That is, you wouldn't say, why did the machine do what it's doing? So the blog argues for that as really where the goal for artificial intelligence in particular, but I think really for computing technology overall, I would now generalize it to say if we're going to put computing systems into the work that people do, we should design them to enhance that work. Doesn't mean we won't lose jobs. We may well lose jobs, but the jobs that remain should be good ones, and the new jobs that get created should be good ones. So I think the first step is to be very clear in the moment about what computer systems are good at. So for example, in the current moment, they're much better than human beings, and probably always will be better than human beings, at taking a huge amount of data and
assessing what's in it. So drawing a certain kind of conclusion from what's in the data. Basically statistical inference. I mean, no question they can do that better than we can with much larger data sets. But there are things they're not good at. They're not good at counterfactual reasoning. They aren't human.
We need to find counterfactual reasoning for our students.
Oh, yeah. So, and they're not good at...
It's a good point.
Yeah. So it's what-if reasoning, right? Or it's hypothetical reasoning might be easier to explain. So if I go down this path, what will happen if I go down that? Well, you presumed this. What if this were the case instead? So that whole range of thinking, not just about how the world is right now, but how it might be. Looking at the work to be done, and then, especially in healthcare, and then figuring out what the right thing is to give to the computer system. So I mentioned that I'm doing work with this pediatrician. His patient base is children with complex conditions. So they could be genetic in origin, they could be as a result of an accident, many different, but they have many, many different problems to be dealt with at once. It's not simple. How do you support that care? The computer system can keep track of what multiple different doctors are doing and try to make sure the communication is working. It can't take over the communication. It can help parents in tracking things well. If you look at the other end of the age spectrum, which anyone who has elderly parents will have looked at, there are things that computing technology can do in helping people keep in touch with helping elders keep in touch with the family, helping the family. But there are also many issues to raise. Some people have proposed computing babysitters or computers that would be the companions for older people. I think that's a huge ethical mistake. Yeah, because we know that the social interaction with other human beings is a key to better lives for older people, and it's essential for learning. Children learn from within the context of social interaction. So I'll go back to the healthcare domain. Right? So how should we design systems to help in medical decision making? If we design them to complement what physicians can do by delivering to them information relevant to the case at hand, then they will enhance human agency. If instead we design them so they deliver a diagnosis and then the physician has to contravene that diagnosis, we have removed human agency. And the same thing is true in the justice system. And it's not, this goes back to a very early conversation. So there are predictive systems out there now. If a judge uses that system's conclusion as the answer for what is going to happen, then that's removed human agency and it's probably done harm, at least in some cases. If instead the system presents its results as a piece of evidence to be weighed with everything else the judge is weighing, then you won't have that decrease in human agency. And I think we're really at the point now where we have to think, and that's why I say it's an ethical issue, we have to think very carefully about an issue you raised, the limitations of the computer system. And here the limitation isn't just the algorithm. People talk about biased algorithms. It's the data that they're working off of. How biased is that data? What does it mean? To take it away from some of the more controversial areas in a certain way, until very recently in the United States, gender information wasn't a part of biomedical experiments. Everything was done on, not just on men, human beings, but on male mice. Why? What was the excuse? Well, women have hormones. Well, yes, women have hormones. If you want to try, it was done on relatively young people, not on old people. You give old people the same dosage as young people, you can injure them. Okay? So this is all data that you wouldn't want to generalize from. And of course, that's all we're going to learn over time. you know, it's not like we see all of the options that we should do. So we have to be very careful about what powers we attribute to computer systems. That said, you know, my friends who have Roombas that clean their carpets, they just love them. So there are places to let the computer do its thing. Maybe you're too young to remember Pet Rocks, but and also Cliff Nass and Byron Reeves, and they talk about how easy it is to get even people who are knowledgeable to treat machines as though they were human. When I did my very early data collection of dialogues between people and a computer system, and of course there was no computer system they could have a dialogue with, so the dialogue was, it was before there was the label Wizard of Oz, but it was essentially a Wizard of Oz experiment. I did them in 1972 or 1973, that label was in 1980. And at the end I would tell people that actually, I'm sorry, but it wasn't a computer system. They were really disappointed. So attributing agency, also you've probably seen these psychology experiments. You just have a few balls moving around and they attribute agency to that. So, and I don't think we're going to block that. It's just what we do. So, and there are certainly benefits to assuming that the Roomba can do its thing, right?
Peace of mind.
Yeah, yeah. So I think, again, you know, it's also a matter of design, and it's a matter of, so Vijay Kumar today said, we have to be honest about, intellectual honesty is important. We have to be honest about what the systems can do and can't do, so that at least people have an opportunity to block an inference that might be harmful for them to make about the autonomy of the intelligent system with which they're interacting. Now, you know, people's fear of autonomous robots, that's nothing new. This goes back at least to the Golem of Prague and Frankenstein. So I'm told in Japan people don't have the same kind of fear of robots. They think they're cuddly, so who knows where this comes from. But I think it is, as systems become more autonomous, people become more concerned about what they can and can't do. And I think that ups the ante on their being honest about their limitations. So this is a very big question now, and as with many such questions, I don't have a simple answer. And I don't think that there will be a general answer. I think that it is, and I don't think there's a one-size-fits-all answer. I think that it's part of the design process is to understand where responsibility lies for the behavior of the system.
So baked into the process of design,
yeah,
preordained understanding of responsibility.
Yeah, yeah. What, you know, if the system is going to make this kind of decision, then who's going to be held responsible when it gets it wrong? Yeah, it should be thought about.
Do we do this today, do you think?
I don't think so. I mean, even to take one of my favorite examples, Elon Musk should not have been allowed to call the system he put in his car an autopilot, because it's exactly to your point. It suggests to people that it has an autonomy that it does not have the skill to carry out. So remember, I make no predictions about the future. I'm going to start by saying that I think focusing on trying to build a system that has the same intelligence as a human being is the wrong focus. My quip on this is that we actually know how to replicate human intelligence. They're called children. And the problem with them is they have only human intelligence. So we don't need to do that. From a curiosity point of view, there are many other questions that I think are more compelling, including the questions of how do you build a system, an artificial system, that could work well with and support people. So it's a fine philosophical question. That's really what Turing was saying, is it possible? But I don't think it's how we should focus our scientific and technological development efforts. I also think I also think, though, if we look at where artificial intelligence, and I take the whole field there, is now, it's all in specialized areas, and to get to the kind of intelligence we have is much, much harder. So I'm saying on the one hand, we're not close, and on the other hand, why should we spend our resources on this? It's the wrong use. It's the wrong use of human intellectual resources. It's the wrong use of research funding. We should be working on, there's a lot of use for building smarter systems that do better, that do in individual realms things we consider intelligent in people. Let's go there.